This is practice A for section 8.3. We're going to look at numbers 13 and 14. The vertices of quadrilateral ABCD are given. Draw that quadrilateral in a coordinate plane and show that it is a parallelogram. So how are we going to show that it's a parallelogram? Well, remember you have 4 ways. So we're going to use one of those 4 and some other skills that we need, obviously. Let's plot these points first. That's where point A lives, 1 left, 3 up. Make sure you know the scale on every coordinate plane. Sometimes they're different. There's our quadrilateral. Now, connecting these, you should always use a straight edge. If you do freehand, it's probably not going to look as sharp. So that's what you do first for all of these. Now, you need to show that it is a parallelogram is what it says. So they're telling you basically that this is a parallelogram. You just need to somehow figure out how and why that it is. So we can do this a bunch of different ways. Obviously, we have 4 different ways that we could do it. Okay? It's probably best to pick the way that's easiest and most efficient for you. This is graphed in a coordinate plane, so obviously the shape is exactly the way it looks. It sure does look like a parallelogram. Here's what I'm going to attempt to do. I'm going to attempt to show that one pair of opposite sides are congruent and parallel. Because if I do that, that would definitely be a parallelogram. And the reason I chose that method is, notice how these are horizontal. So anytime they're horizontal, they're parallel to each other. Remember, horizontal segments have a slope of 0. So if they both have the same slope, they're parallel. Also, since these are both horizontal, I can easily count the lengths. 1, 2, 3, 1, 2, 3, 4, 5. That's how long it is from A to B. It's the same thing for segment DC. So what we have here are parallel segments because they have the same slope. They're both 0. That was easy to figure out. And they also have the same length. Since they're horizontal, I was able to count. So we have one pair of opposite sides, parallel and congruent. Number 14, we're going to do the same exact thing. And we're probably not going to use this strategy. I'm assuming it's going to look like a different type of parallelogram. It's going to be orientated differently over here. So let's plot these first. So once you have those plotted, it certainly looks like a parallelogram. You just need to use one of these strategies again to show that it definitely is. This one is, again, going to set up pretty easy, just like this one did. These are vertical, so they have an undefined slope. That means they're both parallel. And since they're vertical, you can count the lengths pretty easily, pretty quickly. They're both 3. So just like this one, you got one pair of opposite sides parallel and congruent.